So we'll talk through two Araf puzzles today and give you some general ideas about how to approach them. This one from Serkan goes by the name Force Field, and I'll shade the fours at the start. We know that the regions you form in these puzzles can't have consecutive digits, so certainly identical digits can't be in the same group, which means everything that I'm shading in dark gray has to be part of a different group. And you'll notice that right now we've shaded 7 cells. There are 13 that are white that could form groups, but there are also 3s and 5s which aren't going to join up with these groups. And one thing you may notice in the solving process is actually if we have 7 4s and 3 5s, there are actually 10 digits that themselves cannot work together. So one trick in this puzzle is to actually shade these and say that these 10 are part of different groups and must join to one of the unshaded cells. This almost now looks like one of the inequality puzzles from earlier in the week, given how that works. And one aspect of this is, for instance, you can go through some sort of thought experiments, like what white circled clue can this 5 reach? Well, it's too many cells are needed to get it to this 3. Too many cells need to get to the 7. It could try to wrap around. It could try to wrap around this way. This is going to be challenging to connect up. And further, this 3 we said can't join with a 4. This 3 has to join with one of the darkened circles, and it turns out there's only one that it can join to. And so the first place I star in this puzzle was to make this group, which is 4 large, so between 3 and 5. And is the only place that this 3 can join. We can make a link that says that these two numbers are going to join. And now from here it's going to be dealing with the remaining clues. So we talked about this 5 going one of two ways. If the 5 went up to the top, it's going to leave just these 4 cells for this group, and this group needs to have at least 5 cells. So a consequence is that this has to stretch down and around this way. That actually gives a fair number of easy placements. The 4, once it joins the 2, needs to be 3 cells. This 4 can't be joined here, and it's not going to join to this group of 5 that's continuing, so it finishes there. This 2 is going to join with one of the 4s. The only 4 it can join with is the one nearest to it. The 5 continues to come around. This group that joins the 5 and 3 has to be a total of 4 cells. Those are the only 4 cells that are available for it. This 4 has to come out somehow. So this kind of marking can be used. The 5 is now rather large and should be clear that what it's going to do is connect to the 21 in this corner. It's actually too large now to connect to anything else. So consequently, that pins where the 2 joins. The 4 and 6 are going to join. The 4 and 12 and this 4 and 7 are going to join. And now you get to a state you'll get at pretty frequently in these puzzles, which is trying to just count the cells, because these values have been set so that they're just enough so that all groups can be filled. So let's start with this group, which has right now 5, 10, 15. This has 18 cells. This right now has 4. It's going to take one more, but only one more in the top, which means this has to come up and that has to come up. So now this group actually has 20. 20 is the maximum it can have. That means that the cell this region takes has to be the one to the left to allow the other cells to form groups. Also run into the fact that this is going to be closed off. Now we still have to take, looks like, a fair number of white cells. This group can take as many as 4 more for a total of 6. So you might sketch that those are the furthest 4 to take. This group up top, which currently has 6, can take another 5. 1, 2, 3, 4, 5. That's an exact number, so we have run into the unique solution of the puzzle, which at the end looks at maximum values for these clues. And while this is a kind of special example because of how the puzzle starts, it hopefully gives you the starting steps that you can apply to a harder example, such as the next puzzle, which was from Prasanna. Unlike Serkan's force field, it has a little more of a challenging set of deductions where you don't always know which kinds of cells are going to come together, but there's a similar kind of logic which gets you started in both the upper left and upper right corners, and that's that you have a cell, for instance, consider this 3, which has a bunch of numbers around it can't join to because they're plus or minus 1 or equal to that 3. So it can't join a 2 or 4 or 3, and it can't get over to this 1 and be small enough to do that, so the 3's got to snake around, and you can draw a bunch of other regions that have to snake too. For instance, the 4 can't join, so it's going to snake over, which means this snakes over. We can think about this 4. It can't join to this cell. It can't join to this cell. It is forced at this moment in time to join to the 1. We can do more snaking logic of that sort. Now that we've broken out on the right side somewhat, we can see that the 4 identical 1s, none of which are going to be in a similar group, are also now at this moment in time limiting and have to come out in this direction. We don't really know yet if these get larger or not. That's going to sort of take some time to discover, but on that side, hopefully that kind of thinking is a pretty clear deduction for how similarly sized numbers were grouped together. And Araf puzzles often start by you just figuring out where those spots are. Like, this isn't as close, these are all odd numbers, and the 3 could join that 5, the 5 could join this 1 or that 3, etc. But look in this corner where we haven't gone yet. This 18 doesn't like any of the 19s around. It doesn't like this 18 here. So it could possibly join to the 20, but it must be the case that it comes out. This 18 connects here, and now this 20 is blocked. It could try to do this, but that's going to take away the path. You should be able to reason out that the 18 and 20 are together and escape somehow down this way. The 18 on the left is going to join to some number beneath it. And now we have 3 different 19 clues, one which might join to the 15, but at least 1 or 2 that have to come out to the right that are going to be somewhat limiting. And what we can in particular do is sort of a similar kind of deduction 3 times, but it starts with this sort of thinking. Let's say the 2 didn't join to this top 19. If it came down and, for instance, joined to this 19, what you've done is pinned an odd number of circles, or effectively pinned this group away from joining to anything. And so you know that the 2 has to join to the top group. And if the same kind of approach, if the 3 joined to this circle or came over here, it's pinning that 19 without a group, so it has to join to something. If we actually do careful keeping and see that this 4 joins to that clue, this 4 now is in a situation where it can't come down and around without blocking how the 3's behaving. And so again, it could join to the circle, but at the expense of pinning that clue. So you can make that kind of connection. And what really you can draw here for sure are those horizontal lines, but those regions are going to connect. And so that just has to do with thinking about pairing circles, even if you don't know exactly how they're going to get paired. The next steps to work on from there are to really think about how this large group, and we actually know, I didn't mention this yet, we know it's going to be 19 cells in total size because it's going to be between 18 and 20. How is this going to actually fill all that space? The largest constraint of this puzzle right now, it's limiting it, is, for instance, not like how large these 99, these clues can be. It's how you get 19 cells into that group. And in the top there are 8, 9, 10, 11, 12, 13, 14. This would be the 15th potential cell, the 16th, and the 17th, and the 18th. And it's going to need to take at least one more in one of these directions. And that's if it took everything that it could over here. But we can see, for instance, that the 2 is going to block off some of those cells. And so this actually takes a few more cells. And what that means is now we don't have a lot of space for some of these other clues to find partners. For instance, the 6 can't join to a 5. That's one away. That's not going to have a region between it. It can't come to this one because that's too far away, 6 total cells. So this region has to be 2, 3, 4, 5. And so it has a potential to join to this 99. But if we do that somehow, what we have are 2 1s which need to both escape down to the bottom. And so hopefully you can see that the only available partner for that 6 is the one to its right. This is now a time you can ask, well, where does this 1 pair? Well, it can't pair to that 5 or this 5 or any of these numbers. It pairs somehow to the 99, which now leaves this 5 as a pretty problematic spot, that it also doesn't have many choices. It can't come to these numbers. It's going to be too far away. Its only option is those 4 cells. So now you say, well, what does this pair to? The 3 has to pair above to the 5. It's going to take 4 total cells. What does this 3 pair with? Well, it can't pair over to the 2, so it's left to just that 1. The corner cells have to be taken, so that is how that group finishes. This 2 has to extend down, but eventually you see that it's going to join to the 18. And so now we get enough constraints on this upper left region for some of these groups. And we don't know about these cells, but we can probably guess that they're going to be forced by filling 19 total cells here. So let's just count how many are left. We still have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And that's the last cell we can take to still allow a path to connect these groups. And so we'll mark that in. We'll mark that whole region in. The last step on the puzzle is going to be deciding which of these 2 groups gets that cell, but if we actually count, we're going to see 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so this puzzle wouldn't have one answer. If this were 16 or higher, it's magically set to the number 15 to give it one solution. And that is how you ended up solving this Araf puzzle. Thanks.